We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
What if I told you that we are going back to the moon for the first time in more than 50 years? And at the same time, millions of people still believe we were never there in the first place. Right now, NASA's Artemis II mission is in progress, with Artemis III and Artemis IV already on the horizon. NASA's Orion spacecraft has completed its journey to the moon, performed a close flyby and sent back stunning new images of the lunar surface, including detailed views of the far side that humans hadn't seen up close in over half a century. The crew traveled farther from Earth than any humans since Apollo, even surpassing the record set by Apollo 13. And every time I read the comments in social media under these missions, I see the same questions. Why go back to the moon? We've already done this. Or wait, have we? To understand Artemis, we need to go back to the beginning, back to the 1960s. This wasn't just science, it was about power, prestige and ideology. The space race between the Soviet Union and the United States defined an entire era. And in the beginning, the Soviet Union was ahead. They launched Sputnik, the first satellite. In the very same year, Laika, the first dog. And then they sent Yuri Gagarin, the first human, into space. In fact, they were even the first to reach the moon with a robotic probe. Their Luna 9 mission sent back the first images from the moon's surface. But here's a fascinating detail. The signals were not properly encrypted. British scientists intercepted the transmission, reconstructed the images, and newspapers in the UK actually published them before the Soviets officially released them. The United States was under enormous pressure and willing to fight back. Then came a defining moment. In 1961, John F. Kennedy announced a bold and almost unthinkable goal: to land a man on the moon and return him safely to Earth before the decade was out. But it was 1 year later, in 1962, at Rice University, that he gave this vision its real power. He stood in front of a crowd and said,
"We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard."
And then he added something even more important.
Because that goal will serve to organize and measure the best of our energies and skills.
This was not just about reaching the moon. It was about proving what a nation and humanity is capable of when it commits to something extraordinary. This was not just a scientific mission, it was a geopolitical statement. Behind the scenes, engineers like Werner von Braun were developing the Saturn V rocket, one of the most powerful machines ever built. On the other side of the Iron Curtain, the Soviet Union had its own brilliant mind, Sergei Korolev, the chief architect of their space program. Under his leadership, the Soviets were working on the N-1 rocket, their answer to Saturn V. But unlike the American rocket, the N-1 never achieved a successful launch. A series of failures ultimately left the Soviet lunar program behind, marking a turning point in the space race. And while the Soviet probe Luna 15 was also heading toward the moon, the United States succeeded in landing humans on its surface. Neil Armstrong took that famous step and history changed forever. But Apollo was not a one-time event, it was a program. Apollo 12, 14, 15, 16 and 17 followed. 6 successful moon landings in total. And then, after Apollo 17, we stopped. No human has set foot on the moon since 1972. And that is exactly where the doubts begin. Today, an estimated 10 to 20% of people believe that the moon landing was staged, that it was filmed in a Hollywood studio. Some of these ideas were popularized in books like The Dark Side of the Moon, which claims NASA staged the landing using film sets and special effects. Pop culture amplified this idea. In Diamonds Are Forever, James Bond walks through a fake moon landing set. In Capricorn 1 with O.J. Simpson, a Mars mission is staged because the real one supposedly failed. Over the years, these theories have evolved and become more detailed, especially for books like The Dark Side of the Moon. For a long time, NASA did not actively respond to these claims. They did not consider them serious enough. But as these theories gained traction, NASA and independent experts eventually addressed them in detail, systematically explaining each claim using physics, engineering, and image science. One of the most common arguments is that the technology in the 1960s simply wasn't advanced enough. People point out that the computers used during Apollo were far less powerful than a modern smartphone, and argue that landing on the moon under those conditions would have been impossible. Others claim that the footage looks too perfect, too cinematic, almost as if it had been directed. They argue that the quality of the images suggests a controlled studio environment rather than a hostile, unpredictable lunar surface. Then there are the visual inconsistencies people often mention. Shadows that don't seem parallel, lighting that appears uneven, or objects that seem too clearly visible despite being in a shadow. These are often interpreted as signs of multiple light sources, like in a film studio. Another frequently cited point is the absence of stars in the sky, which for many seems counterintuitive and therefore suspicious. They also point to the American flag and claim it appears to wave in the wind, even though there is no atmosphere on the moon. They use this as evidence that the scenes were filmed on Earth. Some also argue that the lunar module looks too fragile, almost like it was made out of foil, and question how such a structure could survive the journey through space and land safely on the moon. Radiation is another key argument. Critics often claim that the Van Allen belts would have exposed astronauts to lethal levels of radiation, making the mission impossible. There are also claims about the lack of visible blast crater under the lunar module, suggesting that the engines should have created a much more dramatic impact on the surface. And finally, some argue that the United States had a strong political motivation to fake the landing, simply to win the space race against the Soviet Union, regardless of whether the technology was truly ready. Now let's look at the counter-arguments. Because for every one of these claims there are clear explanations based on physics, engineering, and actual data. Let's start with the idea that the technology in the 1960s wasn't advanced enough. Yes, the Apollo computers were far less powerful than today's smartphones, but that's missing the point. They were highly specialized systems designed for one purpose only: navigation and control. The Apollo guidance computer was one of the first digital computers using integrated circuits, and it worked with incredible efficiency. It didn't need to run apps, it needed to land on the moon, and it did exactly that. What about the claim that the footage looks too perfect? In reality, the footage is far from perfect. It is shaky, overexposed in places, and limited by the technology of the time. What people often interpret as too cinematic is actually the result of high contrast lighting on the moon, where there is no atmosphere to scatter light. Then there are the shadows. On Earth we are used to flat surfaces and atmospheric light scattering. But on the moon, the terrain is uneven and there is no atmosphere. This creates strong contrast and optical effects. Parallel shadows can appear non-parallel in photos due to perspective. This is a well-understood effect in photography. Why are there no stars? Because of exposure settings. The cameras were adjusted for the bright lunar surface and the astronauts' suits. Stars are simply too faint to appear under those conditions. The same thing happens if you take a photo in daylight on Earth. You won't see stars either. What about the flag? It looks like it's waving, but it isn't. The flag had a horizontal rod to keep it extended. When astronauts moved it, it oscillated due to inertia. And because there is no atmosphere on the moon, there is no air resistance to dampen the motion quickly. So it actually moves longer than it would on Earth. Radiation is often misunderstood. Yes, the Van Allen belts are dangerous, but the Apollo missions were carefully planned to pass through the less intense regions and very quickly. The total radiation exposure was measurable but not lethal. This has been confirmed by data from the missions themselves. The lunar module looks fragile, and it was, but it didn't need to be strong like an aircraft. It operated in a vacuum with no air resistance and lower gravity. The thin outer layers were designed to save weight, not to withstand atmospheric forces. In space, different rules apply. What about the missing blast crater? The descent engine of the lunar module was designed to throttle down during landing. It did not create a massive explosion, but instead gently displaced the top layer of lunar dust. And in fact, you can see this dust being blown away in the landing footage. The same principle applied during liftoff from the moon, with the ascent stage ignited to return the astronauts to orbit. And even then, it did not produce a dramatic blast crater, but only a limited disturbance of the surface. And then there's the biggest question of all. Could this really have been faked? NASA and independent scientists point to overwhelming physical evidence. Over 380 kilograms of moon rocks were brought back and studied all over the world. Their composition is fundamentally different from Earth rocks. Retroreflectors were placed on the moon, and to this day, scientists can bounce lasers off them and measure the distance between Earth and the moon with extreme precision. And modern satellites have taken high-resolution images of the Apollo landing sites, showing the descent stages and even the tracks left by astronauts. But perhaps the strongest argument is this. The Apollo program involved around 400,000 people, and it happened during the Cold War. The Soviet Union was monitoring everything, tracking signals, verifying trajectories. If the moon landing had been faked, it would have been the greatest propaganda victory in history for the Soviets to expose it. But they didn't, because there was nothing to expose. And last but not least, if Apollo 11 was faked, why fake 5 more missions? Why increase the risk again and again? It simply does not add up. So when you look at all the evidence together, the physics, the engineering, the data and the historical context, the conclusion becomes very clear. We didn't fake it, we went. And now we are going back. Artemis II is happening right now. Artemis IV aims to land humans again. This time using systems like the lunar Starship from SpaceX or the Blue Moon lander from Blue Origin. Artemis V and beyond aims to build a permanent presence. But why does this matter? Because the moon is not the destination. It is the proving ground for Mars, for deep space, for humanity's future beyond Earth. There is water ice at the moon's poles. There are potential resources like helium-3. There is a rapidly growing new space economy. And there is a new geopolitical competition, especially with China. If the US does not accelerate with Artemis, then China will catch up and might be the first to reach the surface of the moon. But beyond all of this, there is something deeper. Exploration is not just something we do, it is something we are. It is part of our DNA. Since the very beginning of humanity, we have always pushed beyond the horizon, from crossing the oceans to standing on the highest mountains on Earth. George Lee Mallory was once asked why he wanted to climb Mount Everest. He simply answered, because it's there. And that mindset never changed. Explorers like Christopher Columbus sailed into the unknown, not knowing what they would find. Not because they had guarantees, but because they were driven by curiosity. And today, the horizon is no longer the ocean, it is space. The moon is not the end goal, it is the next step. Exploration is in our DNA and it always will be. See you in the next video. Ciao.